Hi, 6th grade. We're going to go over page 216 on Punnett Squares. Hopefully you watched my video from last week and you saw how to do these properly. So we're just going to go through and you're going to check your answers and make sure you fully understand this. So let's look at number 1. Both parents have one dominant gene for curly hair and one recessive gene for straight hair. Let capital H represent curly hair and lowercase h represent straight hair. What is the probability or possibility that one of their children will have curly hair? So let's look back at our question. They said that capital H equals curly and lowercase h equals straight. So we'll draw our Punnett square. All right, and they said a parent has one dominant and one recessive. That means we have one capital H and one lowercase h. And the same on both sides because they both had that. Both parents had that dominant and then recessive. So now we're going to fill in our Punnett square like we always have. So capital H, capital H, capital H, lowercase h. And remember, you're getting these from here and then bringing this down. And then again, we're bringing capital H down. So capital H, then lowercase h. All right, and the same thing, lowercase h, lowercase h. So they want to know what the probability is that one of their children will have curly hair. So we remember that curly hair is our capital H. So what we're going to do is we're going to look here, and then we're going to see we have 1, 2, 3. So we actually have 3 out of 4 that have a possibility of curly hair, or the probability. So our percentage would be 75%. Okay, so that's how we do number 1. All right, let's move to number 2. Okay, for number 2, one parent has 2 dominant genes for an unattached earlobe. The other parent has 2 recessive genes for an unattached earlobe. Let capital E represent unattached earlobes and lowercase e represent attached earlobes. What is the probability or possibility that one of the children will have an attached earlobe? So we're going to let capital E equal our unattached. Okay, and then we're going to let lowercase e represent our attached earlobes. Okay, and it said that one parent has 2 dominant genes and the other parent has 2 recessive. So that means if the one parent that has the 2 dominant, we know it's going to be 2 capitals because they said it's dominant. And the other parent has 2 recessive, so we know it's lowercase e on both of those. So now again, we're going to fill in our Punnett square the way we've been doing it. So capital E, lowercase e, capital E, lowercase e. Oh, here it is again, capital E, lowercase e, capital E, lowercase e. So we can see here that we have capital E, lowercase e in all of them. So the probability of a child with attached earlobe, so remember that's lowercase e, we didn't have that in any of these. We can see here we have a dominant in all of them. So our probability is 0 out of 4. Okay, and we know that if it's 0 out of 4, that means it has to be 0%. Okay, hopefully you're getting those right. All right, let's move on to number 3. All right, number 3. One parent has a dominant gene for a straight thumb and a recessive gene for a bent thumb. The other parent has 2 recessive genes for a bent thumb. Let capital T represent straight thumbs and lowercase t represent bent thumbs. What is the probability or the possibility that one of their children will have a bent thumb? So again, we have capital T is going to represent our straight thumb. Okay, and then our lowercase t is going to represent our bent thumb. All right, so we're going to make our chart. So one parent has a dominant gene for straight and a recessive. So that means a capital and a lowercase. Okay, and the other parent has two recessive. So that means they have two recessive, which is the lowercase. So we're going to put lowercase t. And now we're going to fill in our Punnett square like before. Okay, and they want to know what is the probability that one of their children will have a bent thumb. So remember, the bent thumb is our lowercase t, so we can look here. So it looks like we have 2 out of 4. Sorry, I messed that up a little bit. Out of 4. Okay, and then that means that if we have 2 out of 4, it would be 50%. Okay? Hopefully you're getting all these right still. Let's go on to number 4. All right, looking at number 4. Both parents have a dominant gene for rolling the tongue and a recessive gene for not being able to roll the tongue. Let capital R represent rolling the tongue and lowercase r represent not being able to roll the tongue. What is the probability or possibility that one of their children will be able to roll his tongue? So let's put these out here. We have our capital R, okay, and it's going to represent our rolling. All right, and then our lowercase r is going to represent not being able to roll. All right, so it said both parents have a dominant gene for rolling and a recessive gene for not being able to roll. So that means we have one dominant, one recessive. One dominant, one recessive. So let's fill this out. Capital R, lowercase r, capital R. Remember that capital always goes first. Lowercase r, then lowercase. All right, so it says the probability of a child being able to roll their tongue. So they want to know how many, the probability that their child would be able to roll it. So let's look here again and see. We have 1, 2, 3. So 3 out of 4. So what percentage would that be? Oh, you're right if you said 75%. So there we go. So 3 out of 4 is 75%. So I hope you completely understand this now that you've had 2 videos on it. If you still don't understand it, you need to reach out and let me know. See you guys soon, or hopefully I'll see you soon.